I will clearly explain you what is argument and principal argument. And I hope that after watching this video, you will have no more confusion regarding argument and principal argument. So let us first draw axis on eigenplan. Okay, and suppose this is real axis and this is imaginary axis. This is I will write this as real axis, and this is imaginary axis. I will write this way, and this plane is called eigenplane. Okay, suppose we have a complex number on this point, and there is a line joining this origin to the point where the complex number, suppose complex number here is point is x y, and the complex number in this quadrant will be z equal to x plus I y, where both x and y are positive. And suppose this line makes an angle, this line makes an angle, suppose theta. This line makes an angle theta with the positive real axis. So this line is called positive real axis. So principal argument is the angle. It is the angle made by the line joining the origin and the point of complex number. So in this case, this is the line making angle theta on positive real axis. Always remember, the angle made on the positive real axis, that is called argument or amplitude of the complex number. So in this case, if we draw a perpendicular line, this will be y, this will be x. So in this case, we have tan theta equals to y by x. So this implies that theta equals to tan y by x. So this is the argument. This is the argument of the complex number. This is the argument of the complex number z. Suppose this time complex number lies in the second quadrant. Suppose here somewhere. Then here the complex number will be in this form. It will be minus x plus I y. So this is in second quadrant. Okay. Now suppose this angle is alpha. Now what is the argument of this complex number? Argument means the angle made by this line to the positive axis. So this is the positive axis. Okay, so this time here is theta. Argument is theta. Okay, now we have to find what is theta. Okay, so we know that a line from here to here to up to here is pi. Up to here is what? Pi, na? Up to here is pi. So then what is this theta? What is this theta? This theta will be pi minus alpha. So this pi minus alpha will give theta, which is called argument of this complex number. Okay. So what is alpha now? Again, here if we draw a perpendicular line, this is y and this line is x. So from here alpha equals to tangent inverse tangent of y by x. So that's why the argon on this plane will be, so argument will be, argument of this complex number will be pi minus tan inverse of y by x. So this is the argument on second quadrant. Okay, second quadrant. Suppose a complex number lies in the third quadrant. Suppose here this is the line joining the complex number to the origin, and this complex number is lying here. It will be minus x minus I y. And suppose this is making an angle theta with x-axis, angle beta, suppose angle beta. Then what is the argument of this complex number this time? Now it is in third quadrant. So remember again, argument is the angle made by this line to the positive real axis, this axis. Okay, this axis means we could have traveled from here to in anti-clockwise like this up to here. Now if we move like this, how much we get? If we move like this up to here is pi, so it is up to here, it will be pi plus beta. But this is not considered as, this will not be considered as principal argument because this angle is greater than pi. So we have to always remember that the principal argument always lies between minus pi and pi. So this is very important range that we have to remember. So argument value will always be between minus pi and pi. That's why to measure the argument of the complex number lying in the third quadrant, we cannot move anti-clockwise. But we have to move clockwise. In this direction we have to move. So this time theta will be this one. Okay, theta will be this one. And also when we are moving anti-clockwise, we have to take negative. Okay, so we know that from here to here it is pi, minus pi, na? So we are moving in clockwise, so we take minus. So from here to here it is pi, from here to here it is pi, and now we want this angle. This angle is nothing but pi minus beta. So this angle is beta. Okay, now what is beta again? Pi minus beta is nothing but tan inverse of y by x. So removing the bracket, minus pi plus tan inverse of y by x. So when the complex number is in the third quadrant, this is the argument. This is theta. Okay, so this is the argument. Now if the complex number lies in the fourth quadrant like this, suppose it is somewhere here, x minus I y, then what is the argument or amplitude of this complex number? So we don't have to move this time. Also we don't have to move like this. If we move like this, it will be greater than pi, so which is not allowed in case of principal argument. So we have to measure clockwise like this. So this is theta this time. So this theta must be equal to, so we are moving clockwise, so we take that's why we take negative. So this theta must be equal to negative tan inverse y by x. So I hope that you are now clear the concept of principal argument and what will be the argument on different quadrants. Okay, this is called principal argument. Principal argument means the unique value of the angle. Suppose once again I am drawing the figure here. What is the unique value mean? Okay, So from here, suppose we have an angle theta. So theta can have infinitely many numbers, so many values. So theta can be measured in different ways. कोई डायरेक्ट ऐसा थीटा ऐसा भी ड्रॉ कर सकता है, कोई ऐसे करके एक राउंड मारने के बाद इसको कोई एक पूरा एक राउंड मार के इसको भी थीटा बोल सकता है. ये केस में क्या हो गया, पाई प्लस थीटा हो गया. और एक बार गुण लिया, फिर ये एक बार गुण लिया, नहीं ये 2 पाई थीटा हो गया. इस तरह से 2 बार गुण लिया, 3 पाई प्लस थीटा हो सकता है. अलग अलग वैल्यू हो सकता है, लेकिन ये सब का वैल्यू सेम है. ठीक है. सो थीटा को मेजर करने का तरीका अलग अलग हो सकता है, इसलिए वो कंसेप्ट आ जाता है. तो हम क्या बोलेंगे, जनरल आर्ग्यूमेंट बोलेंगे. जनरल आर्ग्यूमेंट, इसलिए जनरल आर्ग्यूमेंट इज डिनोटेड बाय कैपिटल A और Z, which is equal to principal argument plus 2k pi, where k is an integer. So this is the difference between argument and principal argument and general argument. So to find the general argument, first we have to find the principal argument, which is the unique value of theta. Then we have to just add 2k pi, where k is an integer, and it becomes general argument. So this is the very basic difference between principal argument and general argument. Okay. So once again you can see argument in the first quadrant is tan inverse of xy. Argument in the second quadrant is pi minus tan inverse of xy, and argument in the third quadrant will be this one, minus pi plus tan inverse of y by x, and argument in the fourth quadrant will be minus of tan inverse y by x. So this minus, so when we move or when we measure in the clockwise direction, we always get negative. We always put negative. So the principal argument in the third quadrant and fourth quadrant will be negative, and principal argument in the first quadrant and second quadrant will be positive. So that's all.